part 2 of leveling effect. So in this we will start with one question. So you might have seen that in organic reactions, whenever we use this base, which is sodamide, this is sodamide, we always use this in liquid ammonia as a solvent. This liquid ammonia is used as a solvent. We never use sodamide as a base in water. So why is it so? So sodamide is used as a base where imide ions, they act as base. Sodium ion they are just spectators, they don't participate in the reaction. So this is acting as a base. Now suppose, just for a moment, if we suppose that we dissolve this in water and use it as a base. Now if we use imide ion in water, for example, okay, we're just taking the example to see what happens that if we do it this way. If we dissolve amide ion in water, so they will abstract this proton and will convert this to ammonia NH3 plus OH negative ion. Now if you focus on this equilibrium, you will see that the negative charge in the reactant side is on nitrogen, on the product side it is on oxygen. And from our knowledge of electronegativity, we know that oxygen's electronegativity is more than that of nitrogen. Okay, we are talking about electronegativity. And a more electronegative atom can better accommodate negative charge. Okay, negative charge. Fine, which means that oxygen can better accommodate negative charge, so it would be more stable. So this is more stable and this is less stable. What does it mean? Reactions go towards stability, so it means that the forward equilibrium, or in the equilibrium, the forward reaction is favored. It is favored. It means that the base which we were planning, so we were planning to use this as a base, okay, but it ended up getting consumed in the solvent. So it got converted to ammonia in the reaction. So the base NH2 negative is no longer available. Okay, so if you dissolve sodamide in water, the amide ions get consumed by water, which is used as a solvent, and what we get is we get OH negative ion. So what does this mean? What conclusion can we draw from this? We can draw the conclusion that we cannot use a solvent, so a base which is a base stronger than hydroxide ion should not be used in aqueous media or in water, because if you use a base which is stronger than OH negative ion, by a stronger base we mean stronger base implies which is eager to, can more readily abstract proton. Okay, so if a base is more ready to abstract proton as compared to OH negative, then it will abstract the proton and get consumed. So in an aqueous media, we should never use a base which is stronger than OH negative ion. That is one of the conclusions. Please keep this in mind. This is the conclusion which we have drawn. Now, if we are using ammonia as a solvent for sodamide, what happens then? So you're using imide ions from sodamide, you're dissolving this in ammonia, which is this thing. This will abstract the proton from ammonia. Okay, so what you will be getting is NH3 plus NH2 negative. So again you have the amide ions available which can act as a base in the reaction. So that is why we always use sodamide in ammonia as a solvent. Now the third thing is that we should never use a base which is stronger than amide ion in ammonia. We should never use this. Why? So if you have a base which is stronger, which is a strong base, and you use ammonia as a solvent, okay, so in case of any question, what you can do is you can start writing that reaction, see where the equilibrium will go. Okay, so this base, because it is strong base, so it will have high tendency to abstract the proton. Okay, so what we will get is BH plus NH2 negative. So the base got consumed in ammonia. You don't have B negative left here. Okay, so we should never use a base which is stronger than ammonia, stronger than the amide ion in ammonia as a solvent. So if we have to use a base which is stronger than amide ions and ammonia, then we should not use ammonia as a solvent. Instead, we should use a solvent which is not that, which cannot should not readily give its protons. That is the choice of the solvent. For example, we have hexane, heptane, etc. So those are alkanes. They cannot easily give their protons. So they can be used with those such type of bases during the organic reactions. So in nutshell, what we can say that the leveling effect helps us in predicting the strongest base or strongest acid that can be used in a particular solvent. Because in organic reactions, you use most of the organic reactions in solvents. So you should, so while choosing the solvents, so you should be mindful of what base you are or what acid you are going to use. So in aqueous media, by aqueous media I mean water, you should never use a base which is stronger than OH negative, and you should not avoid this. Okay, and in the acidic media, in the aqueous media, the base is like this. Okay, and the ammonia, the base should never be stronger than NH2 negative. Okay, and in acidic solution, in acid solution, if you are using an acid, the acid which you are using should not be stronger than the conjugate acid of solvent. Okay,